Right, hello everyone and welcome to the Midas Gen webinar for basic training on numerical modelling of buildings for steel frame buildings and concrete flat slab structures integrated with BIM. So my name's Adam Kane and I'm going to be taking you through proceedings today. First of all, just spend about 20 to 30 seconds doing a quick sound check, making sure everybody's in the room. So if you could just raise your hand quickly or place a comment on or in the go-to meeting dialog box, and then I'll continue. Okay, so I see a few of you have raised your hands, and I will just start and take you through proceedings, so thank you very much. Right, just go through some of the general housekeeping rules. I know that you can hear me, and but if you can't, then your computer is set to mute or in a very low volume if it's muffled. If you want to maximize the screen, just click on the two overlaying boxes in the top right hand corner, and if your screensaver happens to kick in, then either wiggle the mouse or make sure you set it to off now in your settings. So just using the go to webinar dialog box, if you click on the red arrow, it will minimize the dialog box to a thin strip. If you'd like to ask any questions, you can throughout, and we'll respond to them either vocally or we'll answer the question in text form. So just give you a brief introduction, or the briefest of introductions, to Midas. We are a world-leading engineering software solution developer and distributor. We do have the #1 market share in terms of civil engineering software solutions. We have over 450 engineers and professionals working with the company, where we distribute in over 120 countries. We have 10,000 clients and we've distributed over 30,000 products worldwide. So here you see the global map, which represents our network across the world. The red, or the bright red dot, is our headquarters, or our main headquarters. The 10 additional red dots are support centres, and you can see that London is highlighted there in England, and all the other blue dots are our distributors. So we do provide the complete software solution package. I'm just going to briefly go through this. Today I'm going to go through the Midas Gen. We also do the bridges and civil engineering, and we also do geotechnical and tunnelling in 2D and 3D, and we've even got the mechanical engineering software as well. We do provide the free training, so this is not only on site, but we also provide it in sessions like this, which are web-based, and we do have question and answer systems. If you do have any bespoke needs, then we can provide you with training in-house to do with these, or set up a web-based training session. So just want to briefly touch on what we're going to go through today. So just going to start from 1, go way down through 6. We're going to focus on the structural analysis models generated from BIM software like Revit. So we will be taking 2 Revit models over from the software, one steel structure and one concrete structure. Then we'll be carrying out the analysis of a concrete slab and walls after meshing, which is also the Revit model. And then we'll be moving on to modelling complex geometries within Midas Gen, and then we'll be looking at the Eurocode specific design checks for steel and reinforced concrete members, and then onto optimal design of steel structures, and then we'll be creating a detailed design report for the steel and reinforced concrete. So I'm just going to take you over into the Revit modelling space. So here we have our reinforced concrete Revit model. As you can see, we've got all of the openings and the slabs and the walls as well, along with the stairwells and everything. So just want to show you the analytical model that's been generated, and just switch on some of the nodes just so you can see that nodal connectivity between the walls and the slabs themselves. So as you can see, the nodes have just come up there. This is essential for any good Revit model that is generated, to make sure that there is the nodal connectivity, because if the walls aren't connected to the floors, then it would just be literally a flat pack building. So I've just showed you that quickly. I just want to take you to the external tools. So as you see here at the top, you can just choose the file location, everything like that, and then just underneath you can select the mesh size. So what we generally go for is a very fine mesh, depending on the building size and how detailed you want the analysis to be carried out. Just underneath you've got your export target, so you can just change what you want to bring across. And then there's also the unit conversion, so just to make sure you got the units correct when you're taking it over into Gen. And we've just got all the section database, and we can even change the standard for the concrete and also for the steel before it comes over. So there's just changing the graded concrete and steel there. So for this, we're just, instead of sending it and wasting a bit of time, we're just going to show you the actual import straight in Gen and show you the actual file. So here we have the graphic user interface, and I just want to go up to new and then just import the file itself. So it does come up as a MGT file, which is basically a text file that will come over into Midas Gen itself with the program language. Just bear with it a couple of seconds. As you can see, it's come across. I just want to switch off the node just so you can visually see it, but as you can see, a fine mesh has just come over from Revit over into Gen without any problems or any glitches. Now we can just change the different display options. Just want to change it to give it a real thickness so you can actually visually see it. So there you go, there's the thickness of the walls and also of the columns and also of the slabs as well. So it has taken account of all the slab openings, and you've even got the story data going up through, so from level 1 up through level 6. And as you see in the works tree, then we've got all of our sections have come across, and we can even just isolate those. Those are some of the columns, and we just look at the properties and you can manipulate those there. So just to reactivate everything, as you can visually see, just want to quickly show you how we can just put some of the static load cases on, and then just want to quickly carry out the analysis to show you how fast and effective it is to take a Revit model and bring it straight over into Midas Gen. Just to briefly explain that the link between the two has been dramatically improved in the latest release, so it really is just a quick and easy process. So just to quickly put the self weight on and then do the load. Now that I've just put that self weight on, just check all the plates throughout the whole building. So just selecting all the floors quickly. So I just want to put a pressure load on each one of the floors just to represent the dead load and the live load. So just put the live load quickly on, -5, and then just to also do the dead load as well. So just to quickly put the dead load on as well. There you go. Let's click apply. Wait a couple of seconds. Obviously there's a lot of plates, so it's going to take a little bit of time to just put the load on all of them. Going up through and making sure it's displayed properly. So those are all the loads applied for each individual floor. Just want to make sure I've just undisplayed those. So we're just going to slow down. Generate all the plates. So let's quickly show you visually. You can zoom into any area. Just want to show you that. So just by using a window, just to quickly zoom in, as you see the loads are applied there to each segment. I just want to undisplay it because you see it was slowing it down slightly. Now just apply the wind loading to the side of the building, so just want to add that. This is done as per the Eurocode. So it's just working my way around. As you can see, you can change any of the values throughout. And we're just going to put that on in the X direction and also in the Y direction. So let's do. Just got to generate the story data and the wind story data. Also generate that quickly. Okay, so you see there it's been generated for the wind loading, so I'm just going to go back to the lateral loads and apply them. Okay, just add that, as I said, to the Eurocode. Selected. Right, now I just want that in the X direction and the Y direction. It'll be focused on the center of the building, so there you see the wind profile. So click apply. Just want that to go in the Y direction as well. Okay, and that's going in a different direction. Just want to make sure that's undisplayed. Just reactivate everything. Right, so now I just want to quickly put the boundary conditions on the bottom, then we'll run through the analysis. So just some simple supports, fixed in all directions, and then just take it straight through the analysis. So you see it's very fast at carrying out the analysis. It should take about a minute or roughly about 90 seconds to just go through this process. In fact, it just took 15 seconds. So that's incredibly fast, and I just want to show you a deformed shape and just illustrate how quick and easy it is to take over from Revit straight into an analytical model. Right, and then you see the deformed shape of the slabs. So let's zoom out. So we can just put the legend details and make sure they're fixed and give us some true values. So we just want that in millimeters. Right, so there's a deformation, so 4.6 millimeters there in the legend. Sorry, just had a couple of questions come in, so I'm just gonna pull up the chat box and read them across. So, so does it take curved geometry from Revit? Yes, it does. We can take any complex geometry over from Revit and bring it into Gen. Sorry, hang on. Oh, can you apply the wind loading to BS, so British Standard? Yes, we can. That's just a simple selection, so we're just going to go up to loads and just show you quickly lateral loads, wind loads, just add a new one, and as you can see there, it's got the BS standard also in the software, so just selecting it, and you can just select the country, etc. Okay. Right, just to move on, I just want to show you some of the beam diagrams and the bending moment diagrams and everything, and I'll answer a few more questions a bit later on. So there's the beam diagrams, just going up the concrete columns. It's going up the concrete columns, so we can make those exact and also just solid fill, just to give you more of an inkling to see them visually. Just make sure it's in meters. So click apply now. Okay, as you can see there, we can also isolate this as well, so we can just click by plane. Or we can just select the beams themselves, so just select the beams, and there you go, you can just isolate them very quickly. So just go back, just want to check out the load combinations and automatically generate them. So within reinforced concrete we can automatically generate them as per the Eurocode. We can also do the same for the BS standard, just to highlight that, and as you can see all the codes come up and the combinations and just the different serviceability and also the strength combinations. Just go to design. Just want to take you through the reinforced concrete design code. So we just want to select the Eurocode there. Just change it from. Don't worry, I'm just going to leave it in this code. So just look at the partial safety factors for the material property. So we can change any of those. We can manipulate them. Just going down further, just want to carry out a quick column check, and we can also do the design as well. So there we just have the columns will actually come up, so we know the size of them. Just come across. Now we can just check the graphic and see that the reinforcement within the member for both the first and the second member we have highlighted. So everything there. We can look at the PM interactive curve in 3D for both members, and we can also just go and look at the individual member as well, going up through, and look at a more detailed report taking you through each individual part of the code. So just to highlight one thing, I just want to update the rebar. So I just want to go through the capacity of the member. So to show you the actual force and the moment. So as you see here, that's the actual force of the N, and M is the moment. And we see that the member is at 23% capacity and both 23% capacity. Just want to make sure, just select the floor, so just select the second floor, we just activate that. We just want to redraw it quickly, so plenty of shortcuts in the working window for you, and look at it from above. So we're just going to do a quick slab and serviceability low combination. So as you see, they're automatically assigned for you, and we can just go through and just do the design criteria. So we can just look through, and this is the basic design criteria, so we can select which reinforcement members we want to use. So that's for the top and bottom. We can also give the spacing and the depth. So we just want to say we want 50mm cover to the members. We have got the units in meters, so we can select that. Okay, just click OK. So now we just go up to the slab fractional design, and we just select the whole slab, and just do the average nodal check, and then do the rebar. We can select any of the low combinations, and just click on the rebar and just click apply. So I just had a couple more questions come through, so I'm just going to highlight those in a moment. Let's see, we just got the P12s at 300mm centres and the P12s at 100 centres. The top and the bottom of the slab. So just to show you the detailed report. So just to go through a couple of questions that came in. So how extensive is the section library? So I take it you mean the section library that comes over from Revit, but what we've done in Gem, we've actually matched the sections library in Revit to make sure that you can have any section to come across, but just to illustrate how many sections are in the database, and here they all are. So we've got everything from the channel all the way through to the I section to T's and everything like that, and all the different codes, and just all the different sections there for each individual one, and that's all up to the BS and the Eurocode standard. You can even look at the calculated results. So and the fourth question that's come in is, how can you analyze steel as well as concrete in one building or in one model? Yes, we can. And we can also import them all into the same model as well, and we can carry out the full analysis and design of a combined steel and reinforced concrete building. That includes all piles and everything like that as well, which I'll show you when we go into the modelling aspect of it. One final question, can it consider cracking in the slabs? And yes, we can consider the cracking, and I'm just going to show you that now. So just update the rebar, and this will go into the works tree. So as you can see there, it just popped up on the right hand side, and you can actually check all the reinforcement and where it is attributed, and we can also manipulate that and change it as well. So just go back to the design aspect again. Just want to quickly just highlight the serviceability checks and the parameters. So just select everything. So we're just going to consider the cracking here, just to apply that serviceability parameter, and we just go up to design and just the slab shear checking. So we just look at the crack section analysis, and we just want to go through the number of iterations and the tolerances. Now we're just going to go back in and just perform the cracked section analysis. Then we'll look at the shear as well. Just a couple of moments and it will just pop up. Okay, another one. Does it follow Eurocode for cracking? Yes, it does follow the Eurocode for the cracking analysis carried out. So it does follow the national annex for the British standard as well. So just going through there, just for the final 10%. Obviously we ran it through a fair few iterations to make sure we got the most accurate results, and that takes a little bit more time. So just to click through, it's just on the 11th iteration. It's going to take another 30 to 40 seconds. So if you have got any questions, please just post them in the dialog box. Right, another one, can we do tapered sections? Yes, we can do tapered sections within the modeling space. I'll just show you the actual tapered section. So we just go into section, and we just go to add, and then go up to tapered. Now we can taper any section. We just got to select the initial section, and then we select the jth end or the second section of the opposite end, and it will automatically do the taper from one end to the other. So it can be linear or it can be parabolic as well, and cubic. Just two more iterations, going down through 19, then just go through 20. I wasn't expecting it to quake. Right. Okay, so that's been calculated now. So get rid of the. So did it take 180 seconds there? Roughly 3 minutes. So now you can just look at the serviceability checks as well. Now we just carried out that for the cracking. Look at the legend and look at the crack points as well on the surface for the concrete. So it'll just take a couple of seconds to go up through. It will get faster as it goes through the checking stage. Fortunately I can't stop this, I can't make it go any faster, so I do apologise. If you wouldn't mind just bearing with me for a minute, then it'll go through. It's really just a highlight that we can do the cracking within Midas Gen. Right, so it's just gone through. As I said, it would go through straight away once it got to a certain point. So So we just look at the crack control, and that's where we need to apply crack control, and then we look at the deflection as well, and that's where all the black crosses are where the cracking is most likely to occur within the modelling space, and we can have that as per legend and have it for millimeters as well, and it will predict the cracking. You can look at it uncracked as well, so we can even take into account the creep for cracking as well, so over a period of time how long it's going to take. But as you can see, it's a cracking of 34 millimeters. Right, so now I've just covered that. We've covered most of the design for the reinforced concrete. Just want to go back and do one more thing though, and just show you the wall design. So one thing, we just got to make sure that we've actually got the walls highlighted, so I just want to reenact all the plates. So just bring everything back online. Because there are a lot of plates, okay. Right, now I just want to select one of these, so we just select by plane. There we go. Now I just want to select one of the walls. So we can also deactivate things as well as activate them. So now that I've got some of the walls, I can just carry out a design of these. See a multitude of different walls there. Select everything, use the load combination or the worst case, and just apply and just click on the rebar, and it will just automatically calculate how much rebar is required throughout the walls and the shear walls with any connecting wall. So you see the reinforcement distribution throughout, and where it's highlighted in red is a more concentrated distribution of reinforcement. Blue is obviously none, as it says in the legend at the top. So now I've done that, we're going to start modelling from scratch. So I just want to open up a new project and literally just start from the very bare bones. So looking at the top view, and what I'm going to do is do basically effectively a floor plan. So first of all, we just want to create or switch on the grid. Make sure we've got the correct spacing. We can manipulate that. It should be set at 1 by 1. So just define the grid. As you see, it's just want to set that as 1 at 1. And just set the boundary conditions. So minus 100 to minus 100 to 100 by 100. Just setting the top and bottom corners. There you see it. Now I just want to create some elements. So just to define the actual overall geometry of the outside of the floor. So these are basically blank elements I'm putting in place here, just so then we'll drag and drop from the works tree to create the overall. Okay, so it's 25 meters in length. I am actually doing this ad hoc, so I do have a plan in place, but just want to make all the elements and bring it into place. So just to extrude the element at the end to give it some depth. So just selected the node and want to take it to a line element. Yep, so just to match the opposite side, so we're just going to translate that node to a line element, so we can just match it to the opposite side, as you can see there. Now I'm going to create an arch going from one to the other using 3 points. So arch by 3 points, just want to make sure I select it, split it up into a number of elements, 15. Select the first point and make sure we get it bang in the middle. So I just want to turn on the snap function, so just snap to the middle. Hang on, yep, so I'll just snap there and snap at the other end. So now, because it's probably a bit unclear on your screen, I'm just going to change the colour. So let's go to display and just change the background colour to white, so as you see it makes it a bit more visual for you. Now that I've created the boundary condition, I'm just going to create some nodal points for some of the columns going up through. So just a basic floor plan, so columns every 4 meters or roughly about that. We just want to have them going along the inside of the building, so making sure they're all in equal distance. Oh, I just want to put that one up slightly so I can use the translate function to move that. So just to show you a bit more functionality within the program, there you go, we just move it by a distance. Just apply that. Okay, that's moved now. I just want to move it in slightly as well. So it's the same function. Let's click apply. Okay, there you go. That's moved to the correct. I just want to mirror that on the other side and show you how it's easy to move them around. We could have just created a new node, but here we can just copy them. So just to use the same translate function, give it a distance and give it the total number. So we just want to actually create the copy function rather than the move function. So then we copy that to the other end. So now we can just show how we can divide nodes as well. So we just want to divide it by 3, I believe. It's a bit of not really trial and error, just want to make sure I get it right first time. So there you go, and that's divided by 3 going from one end to the other. And we're just going to create the ones in the middle as well. And these for the, just want to create the shear walls, so just going to create some lines for the shear walls themselves. So just 3 meters by 4 meters. And then we got that, and now we just want to do the same at the other end of the building. Just line them up slightly with the columns, so a bit of a regular shape. Going up to the top and then back to the middle again. And there we go. So that's going to be our shear walls. So now we've got all of our columns and everything in place, and our shear walls, and also the layout of the floor. I just want to create one more nodal point. So I'm just going to move that node 0.5 meters because I want it slap bang in the middle, so visually it looks correct. Same again, just the translate function, just to move it 0.5 meters in the X direction. There you go, it's just moved straight to the middle now. So that's kind of the flooring plan. This got the layout. This is just going to be strictly steel beams and then a concrete floor, just to show the combination. We're going to have reinforced concrete shear walls as well throughout. And this is just an exercise just to show you some of the geometry. So I'll just continue. So now I'm just going to use the extrude function to create some of the columns. So just go for element, just go to extrude, and now we just want to give it some of the, first of all I'll quickly save it just to make sure we've got an example. So just to say about 4 meters will be ample for a floor, and just click OK. So that is now extruded. We can look at that in the 3D view. As you see, we've got the columns going down. We'll also put some piles as well at the bottom of the building in a moment, so we just want to create a strip footing and everything like that. As you can visually see it. So that's going to select and create the pad for the bottom. So just want to make sure we can create the wall elements first. So just want to translate that down. -4. So you just give it a distance and all the lines and elements. So as you see that, now we just want to do the same for the walls as well. In a moment, so just quickly draft a line across there. So I'm going to go to the top view. There you go. Now just move that down. Just want to select all the nodal points as well to make sure we've got everything before it gets moved or copied. Okay, now I just want to create the mesh for the walls and also for the pad at the bottom as well. So just select it by the nodes. We select the 4 nodes for each individual one. Another way we could do this as well is actually by going to the top view. So I just want to select the 2 areas that we want. So just isolate those. I've got that. So now we've got those 2 areas, all we have to do is just select by the plane. So Z plane, so now we've got in that plane, just go up to the nodes and just go around and select them. There you go. Let's go to apply. Do exactly the same way all the way around. Between each individual section. Now to show you another method of doing it, it's just to create an element along the bottom, and then we can do it by the plane itself. So just to select this and then make sure it's isolated itself. So just look at the building as a whole. To apply the mesh, so just by selecting each individual side we can just apply the mesh even faster than before. There you go, so that's been created. So what I'm really trying to highlight is the different ways you can actually use the program to generate meshes and actually or generate mesh on the outside of each individual structure. So now that's been generated, I can just delete the doors out of the face just by selecting them. Just you could do this by selecting a plane as well, so just to press delete. You see you've got the nodes in them just left behind. There you go, so just only 3 nodes, we can delete them as well. And that's been carried out, so now we can just go back and just show you the whole model, and then go back and put the pad on, and also concentrate on doing the piles as well at the bottom of the structure. So just to quickly select by plane, X and Y, just get the bottom there. So now that we've got that, what I'm going to do is just select the outside and so we're just going to create the nodes. Just want to generate the piles now just throughout. So just to generate one pile using the node to line function, or just to translate it. So just want to extrude that, so just want to make sure it's a good 1 meter, and we're going to multiply it by 10 to make sure we've got a good pile length to show the soil structure interaction we can generate. So that is the pile. Right, so just want to make sure that we just do that one more time. Just take it down another 5 meters. For some reason it came to plus. We must have selected a node in the higher plane. So now that pile has been generated, just want to make sure that we can multiply it. So we're going to put these at, say, every 5 meters. Just to make sure that we've got a number of times, and the building was 25 meters long, so we should say about 5 times. So it should be just an extra meter. Just put 24 divided by 5. So we can actually manipulate it, so we can actually take a distance and then divide it by the amount of times. So that's been applied. So just look at that visually. You say right on the fringe of the building as well. What we can do is just move that inward, so we can just translate it if we want to, and just move it. We can just move it in 2 meters. So there we go. That's all of the piles generated in one line. So what we want to do now is just select all of these and then just multiply them again. So what we can do is just to copy them in the Y direction this time, and just have it so that it's 4 times going to put this over. So divide that by 4. Okay, and that's just generated all the piles at the bottom. Now we're going to concentrate on making the actual pad, and we'll put all the materials and all the element types as well after this. So just to generate a mesh, so just using the auto mesh function by the lines, and just to make sure we just select everything in one plane and just select that. So just generate a mesh. So as you can see, it does account for any irregularities or any holes in the mesh by line elements. You can see we've got the base there, and you can see the outline of the staircase or the lift shaft that's going to be put in place. So just quickly mesh this area, because we don't really want a hole in the foundation. We will want it going up through the other floors. Right, so there we've got the piles and also the foundations. Just close that, and we'll concentrate on all the rest of the floors now. So just go to element. Now we want to carry out a definition of materials and also the elements as well. So just concentrate on the materials first. So just to add a few different steel sections, so it's all up to the BS and Eurocode. So just select for the Eurocode S355, we just want to do the same for the concrete. Make sure we've got the right grade. So we can use a C30 by 37. And then we can just select the section as well. So just to go into sections and just select a few different ones. So we've got the different codes from across the world. Just select the BS in this case, because it's the most commonly used. And then just go down to a different section and just use that. Okay, it's selected section there. Obviously we will be carrying out some steel optimization and things come the end. So just click apply. Yep, thank you. Right, so as you can see, that it has actually taken up and defined every single section. So just want to make sure that we've got everything in place that we need. So we're just going to do the pile now. So this is going to be a concrete pile and a solid round. We just want it to be 0.5 meters. Which use like some of the drag and drop functions. So just select all the piles at the bottom, just to make them all circular. So we can just go up to the sections, and we can just change that by simply dragging and dropping it straight over into the working space, as you see there. Now what we do is generate the floors. So now we're just going to sort this model out quickly, and just the reason why I did it this way and showed you all the actual, I want to show you all the different sections and the ways of making dummy beams and things like that. So we just got to make sure that we keep all of the elements in place, so that when it comes back to it, if we do want to carry out any remeshing, then they're actually still there. So just go and just select some of the different planes. Just want to select the dummy members around the outside. Alright, so let's just change that and do exactly the same thing for the beams at the top. And that's created some dummy beams, so that's just giving us an outline. So we'll do the same for some of the columns on the first floor, where it's around the actual the walls going up, so just select those and we'll just create those into dummy beams as well. Just very quick and easily done. We'll just select that, just bring it across. Okay, so that's all the dummy beams done. So now we're just going to generate the floor. So just go down to the mesh and just use the auto mesh function on the first floor. So we just use it by the line elements, and it will take into account, rightly so, the openings in the slab. So I just want to make sure we select concrete and give it a thickness. So we just want this to be 270 millimeters. That's the floor defined. So just click apply now. And they've given it the real thickness as well. So now that we've just generated the floors and we've even got the openings, we can just basically use this as an outline and select the whole floor and then just multiply it over a number of different floors. Okay, so that's just selecting the whole floor. Let's go out to translate, or we can use the floor. So we just go out to buildings and building generation. So just by simply putting in the number of copies, we can just select 4 for now. I think probably put 3, and then it's 3 additional floors to this one. And then we just want to make sure that the additional floors are 3 meters high rather than 4 meters high. So we've got the lobby area as 3, and then the remainder of the floors will be the lobby area to be 4, and then the remainder of the floors to be 3 meters in height. So just to add that, and then just click the apply. There you go, and there's the whole building's been generated. That's 4 floors going up through. Just flick off the nodes, it makes it easier to visualize. As you see, that is your complete building with reinforced concrete piles, slabs, and steel beams, steel columns going up through, and reinforced concrete walls. So I just want to put a retaining wall around the bottom floor, and what we'll do is I'll take you through some of the applying some saw springs to the piles at the bottom, and we'll also put a load on there so we can just show you the design of the reinforced concrete piles as well. So I just want to briefly do the shear wall, the retaining wall around the outside of the bottom floor. Okay. So just to swivel this around quickly and just do the back of the building. So just to create a retaining structure, just using the mesh by nodes. See there, we just select the nodes. So just select the 4 points around the outside, go all the way to the end, and just click apply. Make sure we select a proper retaining wall, so we want it to be at least 450, well, at least 450. Let's click apply. So there you go, there's a retaining wall at the back, and what I'll do is put some boundary conditions of that. So if you can picture it, then you'd have the earth piled to the back of the wall itself, and we will show the soil pressure in a moment. So just put some pile spring supports first, and we'll concentrate on the piles at the bottom of the structure. And as you see, we just generate the ground level and what soil, so we're just going to change that to make sure it's a clay. So we're going to put it in a soft clay, set the ground level, and we also just put the pile diameter. Now we've got the unit weight of the concrete, the coefficient of subgrade reaction, and we'll just set the value, and we can simply click apply, and it will give you these soil springs going all the way down through. So take into consideration that now that these have been generated, it's a conservative estimate, but you can design the piles from this within Midas Gen. So just go back to the front view, just give it a swivel around, and the side view, and just to show you those spring supports. And now I want to do the earth pressure, and we're just going to create some of the static load cases. So just create the dead load, live load, much as I did before, just to take a couple of seconds. So just the wind in the Y direction and the X direction, and just the ground pressure as well. So just the earth pressure on the back of the wall. Okay, and now just go up to just the loads again. Just to quickly give it some self weight, just go through in a regimented fashion. So that's the self weight being applied to the building. Now we can just go up to the earth pressure loads, or the pressure loads. So we can do the pressure loads on each floor. So I just want to select all the different mesh sets. Just select them all, quickly going down through. We just want to apply the loads. We did this at the start, but I'm just going to quickly do it again. So we're just going to apply the dead load this time, put a live load. So I just do the live load. There you go. That's applied. Now we just want to do the pressure load to the back of the retaining wall. So hydrostatic pressure load. We just select it for the earth pressure, and we just select the reference point. There you go. And we just select the whole of the wall and just apply the load. So we just want that going in. The gradient is in 19. And there you see it. That includes, we can also add it for the hydrostatic pressure load and the earth pressure load as well, depending on the soil conditions. As you see, that is the loading conditions actually applied. So now that all that's done, I just want to make sure we've got the wind loading, and just do the story data, automatically generate that. The only reason I'm putting all these on is so that we can get some design results out for the piles at the bottom, and also the steel, because we're going to carry out the optimization. So I haven't checked the GoToMeeting dialog box in a while, just been concentrating on the modelling. So if you have any questions, I will cover them in a moment. Just want to go in the X direction, and just to change it over so it is in the Y direction. So apply that, so there's the 2 wind loads applied, all the floors been applied. Let's just go through and automatically generate the load combinations for reinforced concrete and steel this time. So automatically for the steel and for the concrete. Just to highlight that it is not a black box, you can delete any number of the load combinations out as per the code that you're working to. So that's all been generated and everything's been applied. So just wanted to take it through the analysis. So just bear with me, some of the analysis has just been carried out. I do apologise, we had a few questions come in, so I'm just going to quickly rattle through them. So while we were doing the piles, this must have come in. So can we do raked piles? Yes, we can do raked piles, so you can do a pile at any angle. It's just considered a column. Can we do pattern loading? Unfortunately, we can't do pattern loading in terms of automatically defining it, but we can do it whereas we can actually select an area and then carry out the patch loading on it. A university lecturer has come in and asked, can we do seismic loads? Yes, we do. We have I think it's 53 or 54 different earthquake loads built into the software, so these are different response spectrums, so we can just select them. We've even got just to show you the time varying. So just for different earthquakes, as you can see, we've got a comprehensive list of different earthquakes that you can select to carry out your seismic analysis on the structure, and we can even design to that as well. So there's all the codes, and you can actually do the response spectrum. We can even do the floor vibration as well, so for the hill drop, walking, jogging, crowd loading, we can also do that as well. We've highlighted that in the presentation previously. And we can even have, just to move on from that, so we can even have moving loads within the program. So say that you've got a crane on top of a building we've worked on previously, you can actually have that moving load moving around the periphery of the building and seeing its worst effects on the elements underneath, or the supporting elements. So okay, so thank you for those questions. So it's good to see that people are interacting with us out there. So now, just to continue, I just want to show you some of the I'm just going to show you some of the design. Just go down through the column design and just go through the design code. So I'm not going to explain this because we did it previously earlier on the presentation, so just go straight through it. So just going to do the laterally braced. Just want to go straight down and just show you the reinforced concrete design and the steel design. So first of all, we do the steel code check for the columns. So we're just going to select one of them. I don't want to waste any time, so just want to define the correct material, reinforced concrete. So okay, I do apologise. That was a user error on my part. So just want to make sure we've got the right elements highlighted. So for everything that's reinforced concrete, just want to make sure it's reinforced concrete. So just want to select the columns and make sure they're still, and now we're just going to carry the analysis again. It only took a couple of seconds last time, so it's okay. So now just taking the steel members, just want to show you the graphic and everything for the output. So this is a one-page summary. As you see, it gives you some of the design parameters and the checking results. It gives you the deflection, and we can also even look at the detail view as well. So show that detailed, and that is the as per the code, or the detailed design that's carried out. So we can check the lateral torsional buckling resistance as well. Just want to get rid of that. So now I just want to show you how to change a column and also to optimize it. But at the moment, surprisingly, the capacity of the beam is only being 15% of the capacity is only being used by the member. So we wouldn't really want that. We want it to increase to maybe say 80%. So what we're going to do now is select something within that range. So these are all the recommended sections that the program's given us. So now we just select one and we just go to change and close. This one, select the thickest section, is probably varied on the lateral buckling. Just want to make sure we check the right capacity. So this is 72%. We just change that, and that's been changed and it's actually satisfied. So now that we've changed that section, we're happy with it. We just want to update the model. So it's going to change all of them. Get rid of the analysis results again. So just carry out the reanalysis, and then I'm going to show you the steel optimization. Now in Midas Gen, it does it as per the unit weight, so the weight of the actual steel column itself, so iterated down. So just go to steel optimal design. You see there, so we just want to select this element, and we just want to just carry out the design in the analysis again. So this will give us some options. So we're just going to change the different internal external for the column design. And now that we've just done that, it'll just take a couple of seconds because it's obviously got to carry out the reanalysis again. Oh, just another one. We've has it selected all the steel members? Yes, it has. So it will change all of them. For one section, we can obviously split them up into different floors if we so wish. We do want to be more or less conservative in our efforts. So just look at the graphic report. You see it's got all the graphical reports in the background. We can also look at a text report as well, where it just highlight the saving in steel. So you can see has actually changed the value, but generally it will change the value of the steel and the ratios and everything like that. And it will change the total weight. So we've obviously picked a decent section for this, so it hasn't actually iterated it down. So just give you some of the design results and everything like that. Right, so now just to show you some of the pile design as well. So just go up to concrete code design, and it is considered to be a column, so we just select the column. This is a highlight. The reason why it didn't select a different column in the optimization was because we'd already selected one at 75% capacity of the beam, and it didn't find anything of a lesser weight within that bracket. I'm sure that if we'd selected a much heftier beam, then it would have selected something different. It would have given some different results. So these are the design results for the reinforced concrete pile. As you can see, it gives you the diameter, the number of bars, spacing, everything like that. It also gives you the interactive curve. We've also got the P-wires in the PM interactive curve as well in 3D, and we can look at all the same reports and everything like that. So now that we've highlighted that, we can just draw the PM active curve, and we can just close that. So what I'm going to do now is I'm going to generate something called a dynamic report. So I know I've gone over the time, so I'm really sorry I can't answer any more questions, so I'm just going to literally move on, and we're going to have to answer the questions in an email after. So just going to save some of the different views. What we can do within Midas Gen, we can actually just by right clicking, you can save any image or any view of the building. So what I'm going to do is quickly go through and select some different viewpoints, and we can just highlight that, and we can actually take screenshots essentially of the modeling space. So just to look at, I'm going to do them at random. It's not going to be, well, it's not going to be pretty. It's going to be plenty of pretty colours, but I just want to quickly get through this. You see there, just taking a few screenshots. So just look at the plate forces. So just save that as a plate force. Just save that as an image. Just want to get some of the table output as well, and also a small bill of quantities will come up automatically within the program. So just look at the worst case. Just we can put that into dynamic report as well. So make sure we're just taking off some of these. You have auto sorting functions within this as well, so we can actually manipulate it and float the worst case up to the top. So just go back to the main view. So just to create the dynamic report. Right, so there we just highlight the reports tree, and what we can see, you can actually write in it. You've got all of the same report options at the top of Word as well, so as you see it's hidden at the moment, but we can visualize that, and you can use any one of the Word functions, and it doesn't matter which version of Word either. You can use it and you can open it up in the model. This has got plenty of place, so as you can see it's just brought that model across from a simple drag and drop. The same with the next model with some of the images, and we'll do the same with some of the tables as well. So just do drag and drop that one table with the reactions, and just go back all the way to the end. Just go into the model view, and I just want to take out a couple of the columns. I just want to highlight some of the floors, so just going to highlight one floor, the top one, and what we do is just remove that. And as it only took a short period of time to do the analysis again, just carry out the analysis, Yep, just continue, update the story data as required. Give you a bit of a prompt before it does anything. And then just carry out the analysis really quickly, and then it will show you in the dynamic report that it is actually changed. So there you go, and we just hit the regenerate button. It will tell us what images need to be changed, so just change all of them, all the tables as well, and everything will change within the report. So just take a couple of moments for everything to change, and as you can see, everything's changed in the dynamic report. And now what I'll do is take you back to the presentation to close everything off. So that was just a close. Now thank you everybody for attending this webinar. I know it's been a longer one this time. We do have a quota for an hour, so I tried to stop it off there. I didn't want to take it on too long. If you have got any questions, and I'm sure that I've got a few to answer just after, so just post them in the dialog box or just email us on the screen there at uksupport@midasuser.com, or you can phone us, and there's numbers on the screen. We've also got a mailing address as well. All of our content does get uploaded to YouTube, so please make sure to check that out. We are on all the different social media if you wish to follow us, but the key one is YouTube for all your free learning and all that kind of stuff. We're also holding a competition with the ICE for the Student Graduate of the Year competition, and we are holding some ICE webinar sessions as well come mid to late this year. But just wanted to inform you of that, and I will close by saying thank you very much for attending, and goodbye.